So in lab one, we had to build adders using logic and look at their waves and everything to determine the outputs and how to get ones for what we want. And obviously, like in this one, for that, I just realized, yeah, okay. But in our half adder here, it uses two inputs to output our output. It only does up to a couple numbers to that actually add. It's very basic. The waves here just further prove that point of where sum and cry are because this is a um, XOR gate, exclusive OR gate. It only sum is only one when there's only one or an odd number of ones in the circuit. The second one helps us make the increment part, which actually does the math with the adding. It takes the previous design and just plugs it in, makes it a bit more complicated and gives us outputs based on, again, how many ones are in the system. With this input right here, we can set it equal to any value from 0 to 4 and see how that affects it along with the waves is just how it happens, you know. It shows you the inputs and the outputs based on 0 to 3 with increments in there and when it's 1 or 0. For the third part, we built a full adder, which is just two half adders pretty much. Again, with the exclusive OR, that gives us our sum, which means you need an odd number of ones. The C out is just the number that we're at, essentially. Again, with the waves, just an odd number of ones gets you a 1 for your sum. The 4-bit adder just takes the full bit adder and puts it with two of them, which helps us get a Y value. It adds from 0 to 16 all in X with this exclusive OR. It helps us get to the overflow. The Y doesn't need an exclusive OR for this one because the way that this the full adder works, the sum already has the exclusive OR, so we don't need two of them. It was the same thing with the 4-bit adder. This wave chart, we had to make our own different tests for it. I used a couple that were already given to us and in the lab template and then switched them up a bit. The C out only had, yeah, C out and C in only had one in them. The overflow had two, or the C out had multiple, my bad. But the C in only had one in it, and it made different outputs compared to the rest of these. And yeah,